complete summary of when to use the sine law or the cosine law, or maybe both of them together. Now, so in this video, I'm going to go over actually, if you take any triangle, how can you find out, I guess, from three pieces of information that are given, the rest of the information. So what I'm going to do is I'm going to take this triangle. I'm going to label it first for you, just kind of as a reminder. So let's say this vertex is vertex A, and that would also designate this angle A. The opposite side, so the length of that side, is going to be a small a. You can put, for instance, this right here is going to be vertex B. And again, so that will also designate the angle B, and then this is the side B, and then this is the vertex C, and then also this angle C, and this is a small c right here. Now, when you're going to be dealing with triangles, you might be given, as I said, the minimum you need is three pieces of information to be able to find kind of the rest of the remaining information that you have. Now, those three pieces of information could be, a side, and a side. When we know all the sides, maybe it's an angle and a side, or some combination of those. Okay, and because of those three pieces of information that you have, is I've kind of created this, huge kind of long, let me kind of zoom out, this table where it is showing you basically, and I highlighted all the pieces of information that are given to you. So let's say the case in the table, the case number 1, you have the side A, the side B, and then the side C given. And then you don't know any angles, and then what might be better for you to use to find the other pieces of information. And then I highlighted there for you that it's probably wise for you to use the cosine law for this. So that's at the right hand side of the table. So you see there it says sine or cos, and all I'm referring to is there, is it preferable to use sine or is it preferable to use cos? And once you find one piece of information, then you can interchange and use either sine or cos to find all the other stuff that you may need. All right. And then on the right side of the table, I've also kind of highlighted right here, which three pieces were given. And here I said, this is side, and side that was given. And that kind of goes back to congruent triangles. And you may remember, that side, or, angle, side, and all of those. I'm going to come back to this table because I want to, again, summarize and let you know that if you do have three pieces, you can pretty much find out everything else that you need. Now, there are some cases which are ambiguous and might lead to, more than just two triangles. And I'll talk about that, okay? And under what circumstances that happens, and I'll point you out to the video which I did on that ambiguous case as well. So in any regards, okay, so coming back to this, so if you have this triangle, so what can happen? And the first thing that you kind of hope for is that you have a right angle triangle. And if you have a right angled triangle, so if your triangle is kind of like this and you have a right angle triangle, then don't even bother using the sine or cosine law. If you have a right angle triangle and that triangle exists, then in that case, just simply use the trigonometric ratios, because, remember that sine of an angle, let's say sine of some angle, and it could be of these angles A, B, or C, is just simply opposite over hypotenuse. And then, you can do the same thing for cos and then for tangent. So whenever it's a 90-degree triangle, so right angle triangle, don't use sine law or cosine law. Just go ahead and use the actual trigonometric ratio. So that's the first thing that I would want to tell you. Okay. Now, if it turns out that you are dealing with a purely acute triangle where all kind of the angles that you have, it's almost like the one that is drawn here, are less than 90, then yes, you can go ahead and try to use either the sine or cosine law depending on what information is given. And then the same thing is if you have an obtuse triangle. Now this can only happen really with one angle, just because the way that triangles are constructed. If one angle is greater than 90 degrees, that means the other two angles must be less than 90 degrees, because when you add them up together, they have to sum up to 180 degrees. Okay, so in these two instances where you have an acute triangle and then an obtuse triangle, it is worth your time to actually try to see if you can use and apply the sine law or cosine law. All right. Now, if you don't know that you have a right angle triangle, then you can go ahead and use the sine or cosine laws as well. But if you do know that it's a right angle triangle, then just use the trigonometric ratios. So that's the first item that I'll tell you, okay, kind of as a hint as you're going through. Now, the sine laws and cosine laws, so I've written out in here. I have proved both of them, all right? So for the sine law, if you like, I'm going to put up a link up above there. You can kind of see where it's coming from, how to construct it. If you are interested in the cosine law, because you use them kind of in different situations that you have. So for the cosine law, again, I'll put up a link up above there and you can see kind of the derivation. If you're not interested in the derivation and you just want to use the application of them, then you can stick around and then see. So if these are the sine laws and cosine laws, notice that the sine law, you can take the reciprocal. So the kind of pinkish that you have, I put sine on top, and then the blue you can put sine at the bottom. That just depends on what information is given and how you want to use the ratios, but they're identical, right? They're equivalent to each other. The cosine law, okay, is applicable basically, to any of the information that you have. So this is the cosine law right here. I mean, it's kind of repetitive, and so I put A, B, C for the sides, and then capital A, capital B, capital C. So I did it for all of them, but really you just need one of them, and then you can interchange the letters as you like depending on what information is given. Okay, so when can you use these, or when it is ideal to use it? Now, please remember, the assumption is that the triangles actually exist. It can happen that, someone gives you three pieces of information, but actually doesn't give you a triangle. And then you might find out, well, that triangle actually doesn't exist. Okay? So, you can always just kind of double check for yourself if the triangles exist or not. And then you can start applying these, okay, for yourself. And so I'll first kind of talk about and bring you back to congruent triangles, which are kind of useful, if you remember back. Okay, so if you have a triangle or two triangles and you want to try to show that the two triangles are congruent, there were kind of these little nice tricks that we had, right? If someone gave you three pieces of information, you can tell if the two triangles were congruent, meaning equivalent to each other, just by having three pieces, so either angles or sides. And so what we had was we kind of dealt with these situations for congruent triangles. So we knew that two triangles were congruent if their sides were identical. So, if one triangle had the same exact sides, so the lengths of sides as the other, then we knew that it was identical. Now, but what else can actually happen here? Okay, so what are all the possibilities that you can have that are given to you, okay, within here? So I'm going to kind of write them out for you, and then I'm going to come back and discuss them. All right. All right, so welcome back. Okay, so here on the side, so what I did was, there really are just kind of 8 possibilities that can happen if someone gives you 3 pieces of information, so either the sides or the angles. And here the A stands for angle. So I know that it's kind of annoying because I used A also for the vertex, but I hope that you do understand kind of the difference. So in congruent triangles, what I did was I highlighted here in yellow the 4 cases that we use in order to show congruent triangles. Okay, so these were kind of the 4 key cases that you have. And again, so I'm just kind of assuming that we have either an acute or an obtuse triangle within here, because again, if it's 90-degree triangles, you would have been not using the sine or cosine laws in any regards. So these are the 4 different cases. Now, you can read these, from front to back or from back to front. So that's why I didn't highlight some of them. So for instance, you can see there that I have provided you, for example, angle, angle, side, and I highlighted that. But that's exactly the same thing as saying side, angle, angle, because if you read it from the back, okay? So I'm not going to, highlight both of them. I'll just highlight one of them. The other ones are kind of unique, right? Because it doesn't matter if you're reading it from the front or the back, they give you exactly the same thing. For instance, side, side, side. If you read it from the back, it's still side, side, side. Or side, angle, side, read from the back is side, angle, side as well, right? Or angle, side, angle is still angle, side, angle. So really it's the only one is that side, angle, angle, or angle, angle, side. So those 4 cases have shown us that if somebody gives us these pieces of information, we have 2 triangles, then the 2 triangles are congruent. And once we know that they're congruent, they're exactly the same. So all of their sides and all of their angles are going to be identical. This is actually going to help us in understanding these and when we can use sines or cosines. It turns out that, in this table, so what I'm going to do is I'm going to now highlight, okay, all the cases that we have which would have been the same if we had congruency in some way. Okay, I'm going to highlight them in yellow on the right hand side. So in the table, if it's, for example, let's say side A, okay, and then an angle C, that's side, angle, side. Okay, so I'm going to highlight all of these. I'll kind of do it in fast forward fashion, and I'm going to point out to you, that these ones, okay, have a unique triangle. So utilizing the sine and cos for those helps us quite a lot. Okay, so that's the first thing that I'll point out to you. Okay, so I'm just going to highlight those right here. All right, so what I did was with the choices that they would give us, so it's from the 3 pieces of information from the sides or the angles, I kind of highlighted here on the right. Notice that the first one is side, 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 okay, that's in yellow. And then we have side, angle, side, so side, angle, side again, okay, and then angle, angle, side, angle, angle, side, angle, side, angle, okay, and so on. So what I did was I highlighted and noticed that it leaves quite a lot of them kind of filled out, right? So these 4 instances, okay, so side, 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 angle, side, angle, side, angle, and then angle, angle, side, captures for us quite a bit of the information. And it only really leaves us 2 particular cases, which, they're kind of, so both of these are identical. So either, you can say side, side, angle, or angle, side, side. I like to use angle, side, side, if you've watched some of my videos, just because it's much more memorable. And this is the problematic case. Okay, this is the one key problematic case that might arise. Okay, so these 2 are identical, but notice that that's exactly what kind of remains here. So you have angle, side, side, and if I highlight all of them, okay, we'll have them. All right, so notice, so here on the right, what I did was I just highlighted those angle side sides. And then finally at the end, it leaves us kind of one last one, which can happen, and it's angle, angle, angle. Now, it turns out that if you're given this piece of information, if you only know the angles, then neither the sine or the cosine law can help you. It doesn't matter, okay? So this is the only case that really we cannot use with either sine or the cosine. The other one, we have some hope, okay, in terms of using them. And because the convention of using, A, B's, and C's, it doesn't really matter how you label them on the triangle. It's a little bit easier, instead of remembering this entire chart. What I recommend is that you actually try to remember for yourself, okay, this, what is given to you, angle side side or side angle side, kind of from that congruency of triangles. And so this entire table, what you will find is, okay, and if you look through it, okay, right here, notice that for most of them you can use the sine law, or you can try to use the sine law. Now, you are guaranteed, so for instance, okay, if you have in here, these two instances, so if you're given side, 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 then in this case, what I recommend is that you start with the cosine law to find one of the angles, okay? Because you can't use the sine law. And once you find one angle, then you can find any other angle that you please, okay, by using, the actual cosine law. So this one, you would start with that. Now, if you're given also side, angle, side, all right, now within here, so that happens, that side, angle, side, and notice that if you look on the right hand side for that side, angle, side, you'll notice that the first thing that you should kind of use is also cosine, okay? Cosine to be able to find your kind of first piece of information, and then you can find the rest and you can interchange, okay, if needed, for your actual other, if you wanted to find all the other kind of pieces or angles or something like that. So these two, start with the cosine law. Now, the other ones, okay, that you will have, so first, okay, if you are going to be running into angle, side, angle, or you're going to have angle, angle, side, because you are given two angles, just find the other third angle right away if you need it. Now, why do I say that is because remember that if you have two angles in a triangle, you can just say 180 degrees minus the two angles, and that's going to give you the third angle. And once you have your third angle, you can go ahead and easily start using the sine law to find the other sides if you like. So notice that there's kind of a pattern, so you don't have to remember the entire table here. Okay, you kind of just have to remember, these. So the first two, side, 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 is cosine, side, angle, side, again is cosine. And then if you have two angles given, you just kind of start using sine. Now, the last piece, that is left for you, we've already said that we can't use angle, angle, angle. Unfortunately, we won't be able to find any information if that's given. So that leaves us with, angle, side, side, or if you read it in reverse, side, side, angle. In that particular case that you have, when you are given the angle and then two sides, so angle, side, side, the sides are, in one after the other, okay, so as you would have them. Okay, so for instance, if you have a triangle, let's say if I have a triangle like this, so what we're trying to say is that this angle is given, and then you have a side and a side that's given, so this is what we're referring to in these things. So if this angle is given, then maybe this side and this side is given. Okay, so those are in kind of consecutive ways, or maybe this side and this side is given. So that's angle, side, side. All right, so that's what you would have. The last one would have been like this: angle, side, side. Okay, or angle and side, side, like that. So that one case, and I like to kind of give that abbreviation, okay, of ASS, may lead to the ambiguous case, where you may possibly have kind of two triangles. Now, if the angle is obtuse, then you have a unique triangle. If the angle is acute, it may lead you to two different type of triangles. And this is referring to and called, okay, very often, is the ambiguous case, okay, for the sine law or the cosine law. And I'm going to put up a link up above that to that ambiguous case because I talked about it. And this is really the only one that sometimes is a troublemaker for us. All right? And that really just summarizes for us what to do. Now, in this case, I still, okay, would encourage you to try to use the sine law with possibly the ambiguous case if it exists. Just make sure that you understand it, okay? Because if an angle and two sides are given in consecutively, then you can actually use the sine law, okay? So you can certainly use that. And that's really the summary, okay? So this piece of information that you have right here, okay, that I'm just highlighting there for you, that's really what you have to remember. And these ones right here, give you unique results, and you can use the cosine law, meaning unique triangles. So there's no worry at all. These, okay, again, there is no worry at all if you have two angles and a side given. And the preferences, you can start using the sine there. So the only one, okay, is this one, which may lead to some trouble. But if the triangles already exist and they're given to you, then you can just go ahead and use the sine law. All right? And that is the full summary, okay, of when you can use these. So I've created this. But notice this chart is enormous. Like, who the heck is going to be remembering all of that? It is much nicer and easier to get yourself acquainted, and hopefully your teachers actually bring back that congruency, and then because it is related towards the ratios of sines and cosines that we actually use within the proofs, okay? So it's only really just 5 items that you have to kind of remember. So I hope this is helpful. I hope you can make your own notes, and then you can start tackling, any really triangle problems, and then find the sides and angles that you need. All right. Okay. Happy studying, everybody. Good luck. Cheers.